want to say first, thank you very much for coming. This is going to be a talk about PMM 101. If I could ask real quick, does anybody have any experience with PMM? Have you deployed it before? Yeah, a couple people? Okay. Do you have it running in production? Okay, all right. What we're going to walk through here is basically what PMM is all about, and I'll show you some of the screens. And hopefully you'll leave this session with a bit of a comfort over what that acronym means and what it can mean in terms of your own environment. Okay. Just so you have an understanding of where I'm coming from, I've been with Percona about 6 years now. I started as a consultant. I managed the consulting group for a little while, had some roles in between, and now I'm the product manager for not only PMM, but also Percona Extra Backup and Percona Toolkit. So if you have any of those kinds of questions, I'd love to hear them too, any feedback on it. Why are we doing this talk? I will do that. Sure, thank you. So why are we doing this? Because I want to make sure that when you're troubleshooting problems, you have a tool that makes sense. There are lots of tools out there to help you fix things within MySQL. There's scripts you can run, but not all of them give you a perspective over time over what's actually occurring. And if they do give you a perspective, then you're probably paying a considerable amount of money. So I want to show you through Percona how we're able to give you an open source, free to use, no licensing, observability for your database environments. Okay? I also want to make sure that I can show you where to focus your attention so that you're not casting about. You're not just saying, oh, pretty graphs, boss, but actually saying, I can do something with this. Okay? So we're standing on the shoulders of giants. I really like that expression because Percona is built on other companies' technologies. You know, we've had Percona Server for MySQL, which is built on Oracle, all the investment that they do. We're improving, but we're not building from scratch. The same holds true with PMM. So we're taking other products like the very popular open source monitoring platform called Prometheus. They're part of the Cloud Native Foundation now. They've got a lot of traction in the market. A lot of people are starting to use it. Maybe Prometheus is common. You've heard it before. Also, we use the Grafana project. It is also popular. They're here actually sponsoring at our conference. They give you nice visualizations of your metrics data. Okay. Why it matters is it makes it so that we can look at MySQL and MongoDB performance over time and help you identify bottlenecks. Not to be ignored, we also support MariaDB and Proxy SQL. And also, we're started first with Amazon. We can do it for RDS and Aurora. So we can give you observability of all of those products. Okay? And as you heard this morning, Postgres, right? So Postgres is going to be in there soon. There's kind of a hook and crook way to get it in right now, and we're going to make it a first-class citizen later. But it was still so new of an announcement, I didn't get it on the slide deck. What else makes PMM unique? This is not a SaaS. Okay? Not only are you not paying for it, you're also not sending your queries or your activity outside of your network. This is designed to run on your platform. The reason we're doing this is about 3 or 4 years ago, we had a project called PCT, Percona Cloud Tools. And it was great. It did all of this stuff. It had metrics, it had query analytics, but it fell apart because people at some level of organization or security concern said, no, you are not allowed to send queries outside of your network. They must remain here. GDPR or all these other acronyms said you can't do that. So we realized, instead, let's put the service in people's environments. And the third main thing is that we focused on security here. We've got SSL, both between the service you're monitoring, the MySQL or the MongoDB, to the exporter, which the exporter is responsible for fetching metrics, and I'll show you some of those examples in a minute. And also there's SSL between the client and server. So even on your own private network, we're securing that data so it's encrypted. Okay? There's 3 main ways to get PMM. I've got them ordered in the kind of the highest download way. The most popular by far is Docker, and it's as simple as a single Docker command: Docker pull, Docker create, Docker run, and away you go. Really, really easy to deploy if you can wait for the 200 megs to download. Okay. The other way that we've got it is a virtual appliance, which uses the Open Virtualization Format, or OVF, OVA. You might see those when you're downloading appliances. We've used it mostly with VirtualBox, but it also works with VMware. If you have that as your production environment, it can be imported in, so it makes it easy to deploy PMM. And the third method is fairly new. We had it since November. It's an AWS Marketplace. Before that, we had these AMIs that we would push, and you had to kind of figure out what those new AMIs were each release. It was kind of squirrely. But it's much better now. You can just search for the in the marketplace and find it relatively easy. Look for PMM. And the cool thing about it, from your user perspective, is now it's integrated with your billing. We're not charging anything extra for it, but it shows up in your view of all the services that you're paying for as a separate item. So you can say to the boss, hey, you know, I know we have all these 50,000 EC2 instances that I have no idea what they're doing, but this one over here, it's clearly PMM. Okay, so what's involved here? It's a client-server architecture. There's two-way communication going on. So it begins with the server. The server's where I spoke about Prometheus and Grafana and all these other binaries. There's another one called console, which helps us do service discovery. Hey, they're just big words. All that it means is that once you run a couple commands on a client, the server knows everything it needs to know to go and fetch metrics. So what's happening on the client side? Everything is run from a single binary that you call, called PMM admin. That is your like entry point to doing any work with PMM. PMM admin add, admin remove, et cetera, okay? And when you do an add, when you're adding services, when you're saying, hey, I'm on a client and I want to say it's running MySQL, when you do a command of PMM admin MySQL, it's starting some agents. And there's 3 agents that would start by default. One of them is called MySQL DExporter. Its job is to reach into MySQL and pull back statistics and expose them to be scraped. That's how you get your pretty graphs with MySQL threads running, number of threads connected, et cetera, et cetera. The other one is called Node Exporter, which means Linux metrics. How busy are my disks? How many CPUs do I have? How busy are the CPUs, et cetera. Okay? And then the third one is called Query Analytics, or Quan Agent. Quan stands for Query Analytics. And what it does is it reads either performance schema for MySQL or the slow log and decides, aggregates and says, here's all the queries that I saw in the last observed period, and I'm going to submit these into the Query Analytics database. So you don't get any value directly out of Query Analytics, the agent, but it provides for a very rich graphical dashboard of where your slow queries are, and I'll get to that in a second. That Quan agent is also the same one that fetches data from MongoDB if you happen to be running that. It will read the, I don't think it's called the slow log, but it's the same concept. All the queries get written to this one place and it consumes it. Okay, so I got ahead of myself. That one's already done. And so is that one. So what's going on with Prometheus? Prometheus does 2 things, actually. Prometheus is a time series database, and that's really the first half. It says, I can get these metric series, and I can store them in some sort of format on disk. And so what we see here, Prometheus uses a key-value pair system. And the key is composed of the metric series and a bunch of key-value labels. And then the value is a float 64. So you're not able to store strings. If you need to store strings, you need to come up with creative ways to pack them within the curly braces of these labels. Not to overwhelm, I'm not trying to overwhelm. I'm trying to show that basically everything is a string on the left-hand side, and Prometheus doesn't know nor care about what it's scraping. It just knows about, this is part 2 of what Prometheus can do. So part 1 is it stores these metric series locally, a series and a value, and it's just dumb about it. It doesn't know what it means until it's queried for it. And then part 2 is it reaches out to these services. It is a daemon that goes out to these exporters and does basically a curl call against them and fetches back a very long list of key value pairs. In the case of a busy MySQL server, there could be 5,000 or so lines in there. 5,000 metric series being written per second for a busy MySQL server. Okay? And it's got all sorts of logic to help merge that and make it smooth to write it to disk. But the point is, there's a lot of data coming into Prometheus every second. It's a busy, busy server. Okay? So starting with Query Analytics, I've got screen caps. It's actually a much richer experience if I can navigate through it, but I found it slows me down to get out of the presentation and do it. So anyway, this is what we're looking at here is for MySQL showing you where the server has spent its time. And we get that by 2 different directions. One is we look at the classically slow query. You say to me, oh, Michael, you know, anything over 10 seconds is slow. Well, yeah, it is. And that will show up. It'll bubble up on this dashboard as a slow query. But the other way we add it up is we say, hey, you have another query, query B, that runs in 100 milliseconds, but you've run it 1,000 times a second. So that isn't free. MySQL has to do a lot of work to answer that query. That costs CPU time and disk and all that stuff. So it also bubbles up. The point being, when you're looking at this dashboard, you're looking at where MySQL spent its time, sliced and diced by those 2 categories. Okay? And what does it let you do? It lets you zoom in. There's 2 different ways it collects data. I mentioned it does the slow log, which is generally richer, but it can also get the information out of performance schema. So by default, we do it out of performance schema because it's faster. It's enabled by default, I think, since 5.6. Certainly in 5.7, it's turned on. And it's virtually free. I mean, it's got to cost a bit of CPU, but there's no, like the slow log you have to spend time writing the event to disk and then reading it back for the Query Analytic agent So there's overhead to the slow log, okay? But notice, when I drill in, this is what happens when you actually click into the query detail of a single example. So I don't know which one it was, but let's assume it's this first query here. When you click on it, oh, why? Oh, because I clicked on it. When you click on that action right there, it will pop open, and I'll pop out of this at the end and show you how actually it works. But anyway, it gives you a little query example down at the bottom here, and there's only 5 rows. They're enough to get you started, to give you a handle on what's going on. But if you're running Percona server and you're using the slow log, it's a much richer experience. It'll show you what's happening within InnoDB. So as you're diagnosing problems, you're able to kind of take one step further and make a better judgment call on it. Okay? So what else does the tool give you? We're trying to make the tool so that it automates some of the things you'd have to do manually. And they're relatively trivial, but the point is instead of you having to go fetch the explain, we'll show it to you. We'll get that explained for you. So while you're going down and you say, okay, here's my 15 slow queries, I click into the first one. Oh, I recognize the query, but I don't know how it executes. What's the query execution plan? Explain comes up for you. But we don't stop there. We also provide the create table, table status, and indexes. Excuse me one second. And so again, these are things you could easily take this back to the database, but you have to switch screens. You have to remember which server it's on. You have to remember which schema it's in. It's a little bit more thinking. Why don't we just display it for you and let you take action on it? Okay. And the third thing, this isn't something you'll use every day, but you'll use it once in a while when you go, whoa, I'm glad I had that. So if you're familiar with Percona Toolkit, we've got a bunch of summary tools in there. 2 of them are PT Summary and PT MySQL Summary. And the first one is about the OS stuff. It'll give you information about how many CPUs you have in there, what kind of RAM is configured, do you have LVM running, all sorts of Linuxy stuff. And where that's valuable is, one, if you're a Percona customer, the support engineers always ask for that. It's the first thing. You might as well just include it in your issue report. It gives them the lowdown on what your server's built out of. The other part is the corollary of MySQL, PT MySQL Summary. It will give you the same kind of information with the MySQL focus. Okay, and so it'll tell you, over a period of time, these are the users that were logged in. Here's, something about the variables, et cetera, et cetera. One of the little enhancements that we made in a recent release of PMM is that you can download it to a file locally, so that you also then don't have to copy paste this to put it into your tickets. So for Percona customers, this really just moves you ahead. Filing tickets, it reduces that friction. It makes it a little bit easier to get support from Percona. Where the fun stuff is, I think, though, where the eye candy is in Grafana, in Metrics Monitor, what we call it. It's basically the pretty graphs, okay? I talked already a little bit about what Grafana is all about. It takes advantage of this system called templated variables, and what it means is you don't need to go into your dashboards every time you add or remove a node. They just show up automatically. Templated variables are super awesome, okay? Oh, I already mentioned Prometheus. And so what I wanted to show at this point, I wanted to go through a quick example of some of the different dashboards. PMM demo. And we'll start with the home screen. We had a release on Friday, and a couple new features came out of it. And one of the pieces of feedback I got is that your web page takes a long time to load on the home screen. And so we're all witnessing this right now. And what became apparent was that we're trying to do too much. We're trying to iterate really, really quickly with this product, right? And what it means is not so much that there's a poor QA on it, but we miss things like performance testing. So what I want to bring this up for is that we're aware of these kinds of problems, and because we iterated quickly and got these things shipped, it also means that in a quick release, within a couple weeks, we can get them fixed. So what's happening on this main screen right now is it's enumerating each of the database, each of the services that are included. So I've got Mongo and MySQL mostly in this environment. I think I got a Postgres in there somewhere too. Well, each of these little boxes costs some work. And to load this page with only 27 entries is about 350 queries. And so what happens is we get a lot of these that take maybe multiple minutes to fill in. But having said that, if you're running this, we're running this on a $15 a month server. I don't even know where, somewhere in France. And so it's really cheap, right? It's only got 4 cores and so on. I've seen it on other environments where people are putting good quality disk in there and fast CPUs. This thing loads like wildfire. So anyway, not to be discouraged by the slowness of it, but the point is everything is a query against Prometheus and then a graphic displayed to visually represent it. Okay? I'm going to start by showing one of our dashboards here, this trends one. Oops, if I spell it correctly. Prometheus, because it doesn't know anything about the data, lets you express it using a language called PromQL, Prometheus Query Language. And what we're doing with this one is we're showing an overlay for a single host of right now behavior versus a day ago versus a week ago. So in your environment, you might be thinking, this server looks weird. What did it look like yesterday? And how was it running last Monday or last Tuesday? These kinds of dashboards are meant to be easy for you to kind of model against. You can just copy them and modify the host or modify the criteria. Maybe you don't care about comparing CPU usage, but you care about MySQL queries, which in fact I think we already have. But premise meaning is if you can find that metric series in the Prometheus database that was scraped, you can compare it. Maybe you want to compare threads running over time for a given server. Okay. Another one is this cross-server dashboard. I like this one because it helps me understand. Now, it's a bit messy because there's so many servers in here, but it lets you plot, maybe you've got an application group of 15 or 20 servers. You can stack them on top of each other and say, why is there an outlier here? Why does one have more activity than another? Okay? These are designed to be, where do I focus my attention? Let some of these high-level kind of metrics lead you there. So, load averages, CPU busy, MySQL queries per second, all of these kinds of things you should be looking at on a regular basis to say who is different when they shouldn't be different. Okay? In terms of MySQL specific, we've got on the order of about 12 or 14 different dashboards. I like to start my day because I was a DBA, and so I still like to pretend that I've got an environment to care about. That's production, and this is my PMM demo, is my prod environment, for whatever that means. It's still kind of rinky-dink. But anyway, I pretend I'm still a DBA, and I start my day by looking at this dashboard. So the two most important dashboards, graph elements that matter to me are MySQL connections and MySQL client thread activity. And what does that really mean? In the case of MySQL connections, if you start to approach max connections, you're going to get a hard stop to database activity. It's kind of like the emergency brake, nobody else can connect, and the app will appear to be down. So that dashboard is key to watch for trends. What I'm doing right now is looking at 12 days, but through this drop down at the top, I'm going to set it to our max of 30 days. It doesn't take much longer to load because it only looks at interval kind of pieces of data come back. But in this case, it's a synthetic workload. I don't have the pretty ups and downs that you probably do in your own production environments. We're only running sysbench here, so it's all obviously quite flat lines. Same thing goes with client thread activity. This is threads running. Anytime you get over the count of cores in your server and it's sustained at that level, you're probably blocking somewhere. There's not really a magic number, but I like to think of 2 or 3x the cores. If you're sustaining that kind of threads running, you could be looking at a less performant server than otherwise. Okay, so this is a key dashboard for me as well. And I wanted to show, I had somebody ask me about HA in the last session, so I figured I want to bring this one up here. Proxy SQL is not a tool that Percona's written. Rene Canao, I think his name is, he wrote it, and but he's working very closely with Percona, and we're supporting it for PXE, and I think also now for MySQL replication. Basically, this is a load balancer, a high availability solution that is MySQL protocol aware. And the cool thing about it is it's integrated with PMM. We have a specific exporter for it, so you can get queries, metrics back, and you can plot them. So how many nodes are in the host group? Well, in my case, I think I'm supposed to have 3, but I've got one of them in a degraded state right now. So offline hard. Okay. It can show me how many back-end connections are ongoing. It gives you a bunch of different ways that you can slice and dice how busy this high availability solution is for you. Okay, oops, that's the wrong slide deck. So is that one. Okay. Okay, one other thing I wanted to call out, this just shipped on Friday. We're including support for annotations in this release. And really, and you're probably familiar with annotations if you run something like a New Relic or these other APMs out there. What we're showing is what outside events can I show on my dashboard that might correlate to squiggly lines. So I want to say I had an application, get released at 12:34 p.m. Why did the lines go all up and down at 12:35? Well, when I have an annotation drawn on there, everybody's on the same page. You, the developer, the bosses, everybody's going, I see it. Roll it back, or whatever the action needs to be. Annotations can be run from the command line, and that's how they're supposed to be triggered, but I envision that people will integrate them into their code release, or if there's outage conditions, you want to have a computer kind of recording these events for you. Because when you hit enter on the command line, that's when the event's going to be noted. So if the deployment happened and you manually ran it, that's not going to line up. So I'm envisioning that it'll get wrapped into some sort of a syscall as part of your application deployment plan. But I'd love to get some feedback on this. The question is, does the annotation show in the graph? It does. What you need to do, you need to hover over the little triangle at the bottom, and a box will appear with the timestamp and the tags that you've added to it. So in this case, I don't have any tags. I would have just the string, just the application deployment. It'll pop up and it'll say. Yeah. So I guess normally you wouldn't have that many lines. I got a little bit carried away when I was making up this visual. Okay. And the last thing, I just want to call this out because it comes up. Does PMM have alerting? Well, yes, it does. Alerting is available if you use Grafana's alerting. What that means is it's a little bit of manual work. You need to unwind a little bit of these templated variables. You need to use string constants of the host names. In my case, I care about when PMM demo is down because Peter Zaitsev is doing a demo to another customer, and he calls me up after and says, you know what, PMM demo is broken for these nodes. So I figured it was about time I kind of ate my own dog food and made Grafana alerting work. And it turned out to be not that hard. It's all drag and drop. This little red line has a little heart next to it. You can raise it up and down. It's intuitive that way because now I can have different hosts with different levels of activity on it. That's why I've got a graph per host. Okay, I've got 1 minute left. Some real quick, we'll have time for questions and we can talk out in the hall as well. PMM is set up for 30 days retention. In a lot of cases that's not long enough, but just so you're aware why we're doing that, there is no bound. You could set it to whatever you want. In our environment, in this demo environment, which is only about 27 services, 30 days is about half a terabyte of data. So you want to go and do a year, go for it. But you're going to be talking probably about terabytes worth of disk. And when I mentioned earlier that you want high quality drives, that just got expensive real quick. You're talking 4 or 5 terabytes on SSD. Oops, went too far. Also, it's scraping quite aggressively. And I like that as a database guy because now I can say threads running, measured every second. I can give some good feedback to a developer. But if that's too much, if you don't have the resources, then one of the first things you do is you reduce the frequency of polling. And you might set it to 5 seconds. Well, you're going to lose some granularity there. It's a trade-off. But you'll be doing less work on the server. Okay? I mentioned this already a couple times, but it bears repeating. Put in a lot of cores into this box if you can. 4 at a bare minimum. You probably want to be looking at 16 or greater. Okay? You need to spend some money on this box because Prometheus is a bit of a hog. It's doing a lot of work. And also, if you want to, the impact of the exporter, particularly with MySQL, can cause performance impact to your MySQL server. Nothing is free. Observing something costs something somewhere. In the case of table stats, this is an important one to pay attention to. You saw in the keynote this morning, in the 8.0 release, I was super stoked, I didn't know it was coming, about the auto increment and table stats. Ulin mentioned specifically that, that querying information schema was getting a lot faster in newer releases. Well, that means at 5.7 it was pretty slow. So what we have is we have this automatic check at 1,000 tables or more in the database. It will disable table statistics. Well, I kind of like that dashboard. I'll show it to you in a second. It gives you some how big are my tables, who are the busy users in there, et cetera, et cetera. So it's rich, but it's not worth taking down your database so you can see that. Okay. What's on the roadmap? In the next couple releases, we're going to be looking at a Prometheus 2x release. And the advantage there is it's going to use less disk, and it's going to be, I kid you not, a 3 to 10x improvement in terms of performance. It's going to kill it. And what does that mean for you? That means either you're going to need less resources, although I'd caution not to reduce it too much, too aggressively, but it means you can add more nodes to your PMM server than you could before. Okay? We also are going to be adding Postgres support. We're going to make it a first-class citizen. That means that when you do a PMM admin add command, you'll see a Postgres option, which right now all you see is MySQL, MongoDB, and Proxy SQL. We're going to add the 4th for Postgres. We're also looking at speeding up query analytics. Right now it's kind of a dog. Anytime you want to do more than a couple days worth of query review, it's stored in InnoDB tables, but there's literally millions of rows, and it takes more than a trivial amount of time. So it's kind of, it doesn't look very good in the Web 2.0 kind of era. So we're going to be looking at switching up MySQL for a different technology, which is really ironic for a MySQL guy and a MySQL company to be saying, but you got to pick the right tool, right? And I know I'm at the end, so if you're a Percona customer, we've got some really good enhancements. I mentioned it, where you can download files. What we want to get to is you just click a button when you're looking at a server, and a bunch of interesting metrics get pushed up to Percona for us to take action and help you triage a case. I want to say a real quick thanks to our sponsors, particularly Microsoft for being here. They hadn't been a sponsor before, and we're really excited about that partnership with them. And also to Vivek Cortex for being a diamond. And that's it. Any questions?
How do you install it in a quick rundown? You RPM it out and then install a bigger agent?
Well, on the client side, the installation, where is it? There it is. On the client side, it is actually an RPM or a deb package. Or you can download the source and build it yourself. They're all, everything is written in Go. All of the client side is in Go. The server side, we intentionally don't have an RPM-based distribution method. And the reason is we were striving for simplicity of delivery of this. And there's a lot of glue in there. You can legitimately go and deploy your own Prometheus, your own Grafana, and join them. That part's not hard. But getting it working with the PMM admin command so we can simplify addition of nodes and removal and status checking, that took a lot of extra binaries that we wrote that live inside this Docker container. So I've had this request multiple times to have a different, maybe a fourth option that is RPM packages, but we haven't seen a simplified way of getting it working and making it easy for us to support. Because that's part two. I would hate to see it go out through RPMs and then somebody upgrade Grafana and not have it work, and then having my support engineer struggle with diagnosing that only to find that version's drifted. I know it's kind of a trite thing to say, but from our perspective, we don't want to be losing money supporting a free product. So we have to be conscious about how we release it. Are there any limitations on the number of servers it can monitor? You're limited by the resources you put into it. That's what it comes down to. Are your CPUs saturated or not? Are your disks saturated? And so for comparison, I don't know what hardware it's on, but a hosting provider I'm meeting with tomorrow has 1,400 servers on one PMM server instance. So that's considerably larger than my 27 I have, and I'm kind of making this thing break a sweat. I probably couldn't go much past 30 or 35 on this like $15 a month server that we run PMM demo on. So for comparison, I advise customers you'll probably get 100 to 200 instances against one PMM server with like a 16 core, 50 gigs of RAM, middle of the road.
For alerting, that you said based on certain metrics, but if I just want to say up, down, is it easy to configure that?
It's trivially easy. What I'll do is I'll show you an example of it out in the hall. But basically, anytime you can draw a graph on something, and that includes is it up or down, you can draw a threshold against it, and then you can generate an alert against it. Go ahead. Yes, we do. The question is, can you disable query analytics? Yep, there's a couple ways you could go about that. One is just don't add the service, and then it never gets looked at, and that's perfect. If you happen to be running Percona server, you have the option to use the log rate limiting function or facility. Do you use Percona server for MySQL or PXE? No, you don't? Okay. I'm not sure if MariaDB has that functionality or not. Certainly community doesn't or enterprise doesn't. Or you could consider querying against performance schema and observing what that would be, even with your high concurrency environment. But yes, instead of doing this PMM admin MySQL, you could say expressly MySQL metrics only that I want to add. It's just adding a few extra characters to the add command. And then the query analytics doesn't even start up. Okay.
I didn't get what's the way PMM connects to the servers that are being monitored. It's just a connection of MySQL native connection, or?
I'll pull the architecture back up. So it's kind of bidirectional, and we're not really happy about this. We need to fix it. I guess there's no talk after this, right? No? Okay, I'm going to keep going. You guys can roll when you want, but this way I can keep showing more visuals. So what's happening is it's bidirectional. Prometheus is only going one direction. Prometheus is going from the database, from Prometheus server out to the exporters. That means you have to have firewall rules opened up on your clients, which I'm not really a big fan of because security guys are all about like, what are you telling me? I need to have 4 ports open, 5 ports open, and they could be different IP port ranges. It's a mess, right? But this is the model that Prometheus uses. It goes this way and it pulls data back. Query Analytics goes the other way. It consumes logs locally or performance schema, and then it pushes it up to the PMM server. So that's kind of really the place I'd like all of this to work, but it's confusing because we've got both directions for different services. Okay, so Query Analytics pushes up to a well-known port. It's running it to either 80 or 443, depending on how you have Query Analytics configured. Okay.
You can run any one of them. I mean, you can disable and enable the Query Analytics and the metric monitor. They are independent.
Exactly. They're completely independent. We've got some shortcut functions. So PMM admin add and then just the string MySQL actually does three things. It adds the node exporter, the MySQL exporter, and the Query Analytics. Because most people want all three. But you can individually run those commands and just say, I just want Linux metrics or I just want MySQL metrics.
Thank you.
Por eso. Go ahead.
So we have just one instance of PMM right now, but we do have several sites. It's a lot of data. So would a suggestion be per site to have actually the PMM instance there? And then if so, is there any thought maybe down the road of aggregating that to a central PMM server, I guess, for visual?
You broach a very interesting topic. Yeah, the question is, I think, twofold. One is, how do you deal with multi-site? And two, how do you deal with aggregation or roll-ups? I'll start with the second one because it's probably easier to explain. This whole Prometheus business is based on, I think, a project called Borgmon out of Google. And these guys at Prometheus rewrote it, right? So it's all their own logic and code. But the premise is, in a multi-site environment, you'll have one per site, one Prometheus node per site, scraping at a very high resolution, the 1 second interval. So forgetting about PMM, just Prometheus doing work. And then you'll have, at your headquarters, you'll have another central one that scrapes the Prometheus nodes in a hierarchy. And it will scrape them only every 5 seconds. And then as you, the user, you have the option to look at the high level with a Grafana there, or look at each of the sites to drill down to the more specific metrics. Now, PMM doesn't have that functionality. We haven't invested the time to build that hierarchy. But conceptually, it's possible to be done. In terms of multi-site, there's a component here about latency that is really critical. Because you're being aggressive about your scraping every 1 second, your ping times need to be relatively low. Like I'd say if you're running anything over 300 or 400 milliseconds between sites, you're not going to be able to scrape data fast enough. You're going to get, the first one not finishing in the first second when the next scrape is scheduled to be run, and you're going to end up with gaps in your graph. Sometimes they'll succeed, but most of the time they're going to fail, so you're just going to get all these jagged graphs that don't make any sense. So that's the danger of having sites that are far apart and latency. But if you've got 3 sites and they're all close together and the latencies are super low, there's no reason. This thing can query across subnets. It doesn't care what range they're on. As long as it can reach them through the network and get routed. So from a can I just get things working, I go with one server first and then build it out. Only because we don't have that federated approach. If you have 2 PMM servers, they don't know about each other. So you need to be like, oh, servers A through B or whatever, A through D are over here and F through G are over here. Does that help, or did I?
Yeah.
Oh, okay.
That kind of was heading down that road. I didn't know if it was on the roadmap.
It's one of those, like, it hasn't been official yet. People want it, as you're clearly indicating. Okay, you're welcome. Any other questions? Okay. Well, thank you for your time. I appreciate it.